Yeah, thanks for coming. I've got a ton of stuff to talk about. I packed a lot more information into this demo because there's been a lot of new capabilities that have just been launched. So I'm trying to squish that all into the time. And if there's any questions, just launch them in the middle of the discussion. I'm okay with that, and we can have an interactive conversation or save them till the end. So I work on a developer acceleration team at AMD. We focus primarily on the client side of AI, so AI PCs, these sweet little devices that are packed with compute power for AI processing, and we're also involved in a lot of the work in bridging that to the cloud. So how are we combining those two technologies? My team works directly with ISVs and our OEM partners to get their AI apps into market. And so we're kind of end of the line, like get stuff actually into production and built. But I have a whole suite of experts on my team that are full stack involved in, down to the metal, the back end implementations. And we're also developing layers of software to help deploy applications and AI solutions in general out in the market. I'm going to touch a lot of those pieces here. So depending on what you're most interested in, we can dig deeper into any one of them. So the primary discussion here is to talk about what we're calling playbooks. And this is a way to just speed up that developer cycle and get your apps built faster. So I'm going to showcase a couple of key playbooks in the areas of agentic AI coding. We'll walk through how we're making that easier. We'll walk through some of those playbooks. And then I really want to talk about a fundamental shift that's happening underneath that's enabling those playbooks and experiences. And it's a technology that we're building into the ROCm stack called 𝗦𝗲𝗲 and 𝗦𝗲𝗲 routers. So we'll cover a lot of this material as we go forward. Before I get started, kind of a freebie here. Take a picture. Thank you to our marketing team. They've enabled a really great developer program here where you have access to a lot of content, but also some credits to cloud compute. Because these worlds need to live together, so we're developing on the edge, we're also developing on the cloud. Grab your credits and get access to some compute power there on our Instinct class devices. Okay, I want to talk about AI use cases. Over the last couple of years, we've watched these use cases emerge. These are some core use cases that I'm personally following, that I'm very interested in, and I see a lot of changing, a lot of disruption in. And we're looking at things from workflow automation, knowledge bases in general. Gaming is a little bit more emergent. We're starting to see how agentic AI folds into that in a number of different ways. And then historically, we're thinking about coding as its own separate use case. But fundamentally, that's infiltrated everything. I mean, coding isn't even a use case. It's just a foundational layer. So we're going to talk about coding a lot in this presentation, but I want to direct you over to a couple of individuals that are standing in the back. We've got a deep hands-on workshop on coding with agents going on in the next pavilion. So if you're free at 1:15, definitely stop by early. That workshop's standing room only. It's been packed both days. But we'll go into deep hands-on exercises on the machines, building those coding agents. I'm going to talk a lot about that here and showcase just a few highlights of it. So the key theme that I'm really digging into here is this idea of choice that we have. And what's happened in the last 6 months is we have a ton of choices, right? Part of that is AI-assisted coding. Part of it is agentic layer, opening up a lot of options. But there's 3 fundamental modalities of choice that we have at our disposal now. One of them is the quality, like how much performance in the accuracy or the quality of the task. Mostly we think about that in terms of the model we want to reach. Are we going to run a small model? Do we want to run a large foundational model? And then have those trade-offs on costs. I'm going to show you an example of that in the demo. The other thing is locality. And what I mean by that is we can decide whether we want to run on a CPU, a GPU, or an NPU for running locally. And now we can also choose whether we want to split our workload across client and cloud. And in our presentation yesterday, we showed a use case with VLLM router where we're adding semantic filtering so the user can decide on those choices. So as a user, you're setting that policy either in that routing layer or in your agentic layer, and then feeding that into our stack to do the physical routing. So I'll talk a little bit more about that. The other choice you have as we build up these different systems in the consumer space, you may have a laptop, you also may have a node, like an appliance that's just sitting there in the background doing work all the time. And you now have choice about what kind of work is going to be running as a background task versus a foreground interactive task. That's going to change your decision making as well. And then the last, but maybe the most exciting, is modality, right? Just the new models that have hit the market in the last 6 months or so. Omni-modal models, speech models have gotten much more sophisticated. So we're communicating, with these things, right? Not with keyboards anymore. Also, image generation, right? And also vision language models. So adding visual capability to our learning and our research and our development cycle. And then just amazing progress in AI models, text models, LLMs in general. And those are all being integrated in these multimodal, omnimodal experiences. And the industry has not fully standardized on how to do that. How do you serve that? How do you bring that into a single endpoint? But these are choices that we have. And so I'm going to talk through some of the tools that are making those choices easier to make. So I'll dig into this use case, one of the main themes of the discussion for agentic coding. It's a great place to showcase those choices. And in this workshop, you can see some of that, because you're going to define different agents for different tasks, right? You may have that architecture step. You need to get that right. You want to use a larger model for that. Probably even want to push that onto the cloud. But as I'm doing small iterations, even debugging, maybe small feature tweaks, that's something that I could do local. And I can offset either cost or mobility to be able to make that choice and pull those agents locally on my platform. So literally, I was playing with this morning, trying to see if I could come up with some new, fresh example to show you guys. And I was walking through the grounds here, coding on this laptop and still running jobs, iterating on features and debugging code, not connected to the cloud or not connected to Wi-Fi. So that's a choice I have. I can literally be mobile coding with these types of device. So that was kind of a fun exercise. And those choices can be dynamic. So we are quickly moving from static choices. So if you're setting up those semantic filtering rules, it could be a rule, it could be a static rule. And now we're moving to more dynamic choicing. We need to be able to make that routing decision real time and on the fly. Could be based on what the resource availability is, or it could just be some dynamic setting in your workflow, right? If you're in a crunch and that bug is not getting flushed out, okay, it's time to move that off to a more robust model to be able to solve that bug and ground that to zero faster. So I'm going to showcase some of that in this example. While that runs, I'll flip over here quickly to the interface and bring up, yeah, that's good. Okay, so one of the things we did in our stack, ROCm stack, in our tool called Lemonade. Lemonade is the tool that gives us that routing capability, right? So it's abstracting away the back end. You don't have to be ROCm experts. You don't have to be HIP experts. You don't have to be an expert on GPUs or NPUs or CPUs. Lemonade is providing that abstraction and the routing capability. So you're feeding your semantic rules into Lemonade, and then it's making those decisions for you. If you want to use a more robust semantic router, this will plug into things like VLLM router, Open Router, and those tools. But I found on client, it's nice to be able to have something a little bit more lightweight. I don't necessarily want to install the Docker image here in my Windows laptop, although I'm perfectly fine doing that on the cloud. So Lemonade can also take those rules itself and do that semantic filtering. But one of the key aspects of Lemonade, because it's a little bit lower in the stack, we wanted to be able to plug into the agentic layer. So we introduced a new launch feature. So very easily you can go into Lemonade and ask it to launch your favorite tool, whether it's Codex or Claude or Gaia or OpenClaw, all of those agentic frameworks. It's fungible at that point. So now you have these different technologies that can plug together very easily. So in launching that, it'll pull up a list of models. Now the key here, Lemonade was built as a client-centric technology. So some of the default choices it's going to pull up are models that we know will run robustly on platform. So any of these choices that I select, will be routed to the local processor. And depending on the choice of model, Lemonade knows if that's a GGUF file, we'll run that on the GPU. If it's something from our Vitis stack or our FastFlow stack, we know that that model's ready to run on the NPU. Anything else can default back to CPU. So again, a lot of choices here. I'll show you what I did on the walk over. It took about 15 minutes, so I'm not going to run it here. But the first thing was I just asked it a simple task. Okay, build me a weather dashboard. Right, so it goes off and chewed up about 20,000 tokens, ran into a bunch of bugs, and you can see like all the red space. It's iterating on those bugs, and we know how that works. That's not really the demo. The demo is that if you look at the task manager over here, it's just burning up the local GPU, right? The Wi-Fi is silent. I could turn off the Wi-Fi. It's not talking to the cloud, and it's doing that initial planning phase locally on this 𝗦𝗲𝗀𝗀𝗀𝗀 GPU. The second task is then it's got to go through and iterate on that debugging. And there I'm making that choice. Are we converging? I'll let it go one cycle. If it's not going to converge, I'll just flip it over to the cloud model and let it converge there. And after all that, 50,000 tokens or so, this is the beautiful weather dashboard it created. Not particularly impressive. It's like a blank HTML page with a search box, enter your city. So now I'm in the feature planning mode. Okay, I really want a couple graphs, and I want to see a sunny logo when I'm in San Diego, and something a little breezier when I'm here in San Francisco. But that feature iteration, I want to do at the coffee shop, right? I want to be in a creative space. I don't want to be at my desk. I don't want to be in an office space. I want to use the creative energy in the phase where I need it. And so again, I'm going to definitely shift back to my local laptop so I can do that creative iteration work there. So that's one example of what you can do with this stack. Let me switch over to this next topic. Thanks. Okay, so all of this is accessible through these playbooks. We built out a whole suite of playbooks. It's full stack, so if you're a kernel developer, you can go to the playbook and figure out how to write optimized ROCm kernels. If you are a comfy UI user and you just like creating images through an application level interface, there's a playbook in there for you. If you want to be a Lemonade powered user and learn how to integrate that into your own application so that you can abstract away AMD hardware, have cross-platform capability to other vendors, Lemonade can do that, and we have a playbook for you. So I'm going to show you that and do a quick walkthrough of those so you can see them. This came live really just a few weeks ago, and it's launched primarily on the client platforms and Radeon GPU platforms, and we're quickly expanding this to the new Halo box. If you stop by our booth, you can see that. That's the appliance PC that I mentioned before, and that'll be launching in June. And then we're also going to be adding the blueprints from our Epic server and enterprise use cases, as well as Instinct. So great place to go. It's a one-stop shop, so you now have this developer interface, no matter which device you're targeting, and no matter what type of developer you are. There are some really great playbooks here to get started. So if you want to code, you pop in there. It's basically a recipe to set up all of the tools and the environment. It's one thing I'm very passionate about with my team. We just have to make this easier, right? Even if you're developing on, big scale class enterprise GPUs, there's no reason this has to be difficult. Like the user experience here should be uniform, should be accessible across the product stack. That's really the goal here of these different playbooks. The other key thing is all those playbooks are open sourced. So they're sitting out there on a GitHub. You can go there. You can actually see the ones that are not released because it's GitHub, and that GitHub project is public. So you'll go in there and you'll see like a much, much longer list of some really cool capabilities. There's a clustering playbook that's coming out where we've taken a bunch of these 𝗦𝗲𝗀𝗀𝗀𝗀, although like more like in a NUC form factor, stacked those up, and we're running very, very large, 200, 300 billion parameter models. There's a playbook for that. So very exciting. I'd steer you over to the GitHub. So one of those playbooks that I want to run for you here live is on the Omni modal routing. So going back to that idea of choice for multimodality, some of those choices depend on the use case. So if I'm talking to my application, I need to route that inference to a specific place and in a very specific way. If I am asking it to generate an image, I'm also going to ask it to route to maybe a specialized image generation model. So in this use case, I want to showcase how that actually works in 𝗦𝗲𝗲. Now, what 𝗦𝗲𝗲 is actually an embeddable DLL that provides I call it the tracks and the switches to build your applications. The UI that I'm showing you is, essentially it's a sandbox. It's a demo UI that we built, and our open source community, they're constantly packing features into this. So we don't necessarily know exactly what's going to show up in this UI on any given week, because the developers are adding really interesting things. Let's see, they added Mac support a couple months ago. I think they added NVIDIA support last week, and we encourage that, right? Even though this is something a lot of folks at AMD created in its beginning, we want this to proliferate. So where the developer community wants to take this, we're going to let them take that. We've opened up a bi-weekly maintainers meeting, so that team is meeting and governing what shows up into this tool. So let me show you one of the coolest features that showed up is this Omni modal capability. The idea here is, how do you bring a collection of models together that you're going to need for your application? So in like a rich media experience where I want to go and create, draw me an image of a mountain with a train tunnel. So, I need an image gen model for that, but I may want to talk to it also. I'm not going to do the voice because it's so noisy. It's not going to work really great right now. But I may want to interact with it on that audio level. I may want it to talk back to me. If I'm asking it to create a children's book or a children's story, I want it to speak back and like tell the story to my daughter, right, as like a fun experience. So the Omni capability in 𝗦𝗲𝗲 is basically pulling together collections of models and putting the intelligent routing below it. So it knows, based on the context of your query, if I say draw me it knows it needs to route that to a image gen model. If I say narrate a story about this, actually if I say, edit this to add a steam locomotive, here it's actually going to create like a control net layer on that image gen model so that it can do the image editing, and now it's recycling that imaging. And I'll run through a couple of use cases here live. My favorite is at the end when we get to that final image and then it tells me a story about it, because that's like a human experience that is near and dear to me. I think it's very cool. I think I went through an exercise and said, okay, change it to Thomas the Train, because my kid, well, she's 17 now, and in all honesty, like, it's not as cool to her, but it's still a cool use case, and it sort of like channels those memories. Narrative story of this scene. But the main point here is we have all that choice at our disposal now. I didn't have to be an expert to build that. Like all of that machinery, the routing, the assembly of that collection, the type of models that are available, whether they run well on GPUs or NPUs, all that's at my disposal. So the key technology here that's enabling it is part of our ROCm stack. It's going to be available across our platform. Okay, so while that runs, I don't know if you'll be able to hear it. It's not, I don't know if the audio is routing. But it's a really cool experience. It's like in this really like deep, like pensive voice, starts telling a story about this misty mountaintop. And anyway, just a really fun experience. Let me talk about one other choice. I have a few more minutes left. And this is something that we showed yesterday with VLLM router. Now, VLLM router has some very sophisticated semantic filtering. And we can use that, but on the client, that's a bit heavy. So there are cases where I can use an agentic layer to pass on those policies and those rules into that same routing layer and let it make decisions, not just on modality, but on quality or cost or token usage. One of the key use cases that I really like and we showcased yesterday was, I entered my social security number. I said, hey, this is my social security number. What state was I born in? And immediately it grabs that and says, that's personal information based on the rules. We're going to keep that local. So we're going to answer that question, but we're going to run it on your local GPU, NPU. And then, of course, it came back and said, that's a fake social security number. So even the local models are intelligent enough to know, when I'm trying to spoof them. If I give them a phone number, if I give them my name, my place of birth, and that's just one use case. Those semantic rules can be set by your use case, by your agent, by your routing policy based on your application. But I think that's a really great use case for client when we want to keep things local or firewalled. Another use case is cost, right? I think you're all in the same boat. Our company is looking at the cost. I talked to our IT team, and they said, you know, people are asking a lot of really dumb questions on our enterprise server. You know, they're asking like, how many R's in strawberry? Or like, you know, those types of silly things that we're just trying to test system, or hello, how are you? And they want to be able to like push those costs off of the enterprise server because those costs are significant across our industry, right? It's the most disruptive aspect of what's going on. So we can pull that stuff locally. Let's do silly things local. Let's do small tasks local. It's another semantic rule. So we showcased that yesterday running on Azure Cloud as one endpoint, or strict_halo as the local endpoint. And that, again, is infinitely customizable. We're running on Fireworks, we're running on Claude, any remote endpoint. Okay, I just showed you this demo of the collections. Okay, one last set of information about the core tech that I was talking about here. Again, fully open source. So community is building it, contributing it. You can go there, you can see where it's going in the future. It was really invented down here at the back end. It's many things in the stack, but the back end is really, if you think about it, is a device problem, right? There's so many devices. You've got ROCm, you've got Vulkan, you have 𝗦𝗲𝘀𝗀𝗶𝗆, we have Vitis. If you get into the other modalities, you've got Stable Diffusion, Whisper CPP. If you're doing text-to-speech, you've got Kokoro. It was really impossible to tie all that together in a meaningful way, and our developers were taking too long to get those applications to market. So this is where it was born. Make this as simple as possible, as simple as a standard API. So what API do you use there? OpenAI has already solved this problem for us, right? They've created a standard inference endpoint API. Everything we do is based on that standard. So if you're plugging into a standard cloud endpoint, you can just as easily route that work to your local PC. So again, very accessible. And then moving up, we added a bunch of utility. If you've got model management and you're creating these collections, we've got utility for that. We talked about the router. And then the most exciting work right now is happening on the application space. So what the community is building when you give them these tools, it blows my mind every week. Someone built like an app store app, so I can talk to my strict_halo from my phone. People are adding other vendor support, which I think is great. People are adding home media hubs, home assistant hubs, all those use cases which, as a technology company, like we don't necessarily have the time to go do that unless it's a major market segment, but the community of developers, they're passionate about it. A couple weeks ago at the Ubuntu Summit, one of the chief architects stood up and said, this is my passion project right now. I'm just really excited about the work that's happening in this space and encouraging the community to come in and just play, right, and invent. Okay, one shameless marketing plug. I mentioned this Halo box. It's not out yet, but this is the future of what we're doing on agentic AI. So there's a number of projects that I'm working on right now. This box is, if you go down to our booth, you can see it right now. It is the exact same processor that's in these laptops, but now it's in a form factor that you can just plug in and it's completely headless. And we're building up a couple of use cases that are going to be always on. So this is your team of agents that's running nonstop, overnight, in the morning. It's scraping all your GitHub issues. It's scraping all your social media. It's looking at the competitive landscape. And when I sit down in the morning, I open up my Notion dashboard. All that information's been scraped for me and presented in a to-do list. So that's the kind of use case that's coming online with these new devices. So yeah, keep an eye open for that. Come June, there'll be a big announcement. But if you want to check it out, go by the booth. And then lastly, one last call to action is to go to the developer portal, so developer.amd.com. You will see the playbooks. You'll see announcements about Halo. You will see a lot of the use cases that we're building on Lemonade and on the ROCm stack, workshops, new events that are coming to here in San Francisco as well as worldwide. We just did a 4,000 developer workshop in Shanghai. The next one's probably going to be about 10,000 developers. I mean, this is an area we are heavily investing in, and we want to bring meaningful content. So hands-on workshops, coding workshops, developer workshops. So this is the place to keep tabs on that, the developer portal. If you join, you'll get all those notifications, and then there's a bunch of giveies for cloud credits if you want to get on Instinct and do some more serious development up there. If you get in the developer program, you can get credits to go do that work as well. Okay, let me land the plane. Almost out of time, but I think we've got some wiggle room for questions. Yes? 1 minute. Okay. Yeah, what do you got? Anybody want to dig deeper into some of those topics? Yep. June. It'll be announced in June. They're out now. You'll see them, but it'll be launched for ordering in June. I don't know. Yeah, I don't know. I mean, the hardware is fundamentally the same, right? So, yeah, it seems about right for the high end. Yep, yep. I mean, I think a lot of that's memory these days. When I first bought this laptop, it was about a lot cheaper than it was today. Just memory cost, which is another cost function, right? Like if we're thinking about running a small model because it takes less memory, I have the options to do that. Other questions? Okay. All right, folks. Thanks. Easy crowd. Appreciate it.